We live in a world that our ancestors would barely recognize. Around the world, the impact of human ingenuity is now everywhere. We've pushed back the limits of our planet at speeds, depths, and heights that would have left our forebears breathless. Driving all these achievements is humankind's extraordinary gift for invention. Through genius and inspiration, we've created exceptional solutions to complex problems. From the everyday to the spectacular. Some of them good, and some of them not so good. This series celebrates the million ways our great inventions have transformed our world.
It's one small step for man, one giant leap for mankind.
We use it to explore the universe and look deeper into space than ever before. It helps us to generate energy in a sustainable and renewable way.
The use probably changed the quality of our lives, our day-to-day living.
It lets us communicate with each other at the speed of light.
This is a material that has revolutionised the world. Everywhere in your home, it's even in your pocket, your technology uses it, it's used in construction.
Since we have used it, we have lived with light and with protection.
You could either have light, but all the wind and the rain and the weather is coming in, or you can close that hole and, at least you're sheltered, but it's completely dark inside.
It has revolutionized science with so few ingredients.
Sand, chalk, soda, and heat. From that, you create this miracle material.
It is the first material ever to be artificially produced by humans and remains a mystery to science to this day. Glass, one of the most phenomenal materials in human history. Masterpieces made of glass. They look as if they flow like water or reach into the infinity of the sky.
It's hard to imagine what it must have been like to live in a world before glass, because glass is just everywhere. If you think about windows, before glass existed, it would just be a hole in the wall.
Without it, we would probably still cover these holes with linen, parchment, or furs. The invention of this material enables us to look out of glass windows. Even though, at first, glass is neither flat nor transparent.
Glass was originally discovered purely by accident. It was a byproduct of a process that was going on at the time. But somebody was curious enough to look into it, to try and work out how you make this on purpose. And that was the beginning of glass making.
Long ago, Stone Age people were already using natural glass, such as obsidian, which is created during volcanic eruptions. Glass production begins in 2200 BC in Mesopotamia. It remains a mystery how the Sumerians found out that glass could also be made by people. From 1500 BC onwards, the Egyptians improved the production process of the first hollow vessels. The oldest hollow glass object found so far is this vase, a burial gift of the pharaoh Thutmose III. The history of its invention begins with curiosity. Today, however, we can use glass to satisfy far greater curiosity, exploring the universe and the origin of all life. Without glass, spectacular events would be pure magic without a scientific background. But all this changes with an invention.
At the beginning of the 17th century, Galileo Galilei looked up to the heavens to investigate the stars above us. But what he needed to see clearly was glass.
For a long time, being able to see long distances by using glass is impossible. This only changed with the invention of the spectacle lens in the 14th century. It was a spectacle maker, Hans Lippershey, who invented the first telescope in 1608. 2 years later, to try and prove a theory, Galileo Galilei improved the telescope and, in doing so, changed our view of the world.
Using this very early telescope, a refractive telescope in fact, he was able to show that it's far simpler to explain that the sun is at the centre and all the other planets are simply going around in things very close to circles. The heliocentric model of the solar system is essentially what he proved.
This is the beginning of the shared history of glass and astronomy. Today, however, there are completely different requirements for glass. Observing the stars is a huge challenge.
It's no longer just about the scientific method, it's about precision optics.
Since 2005, the European Space Agency has been planning the construction of the largest reflecting telescope in the world. The ELT is scheduled for completion in 2025 and will be located in the Atacama Desert in Chile.
Astronomers are incredibly inventive when it comes to naming their telescopes. One of the biggest telescopes currently in use in the world is called the VLT, or the Very Large Telescope. And there was a proposal to build an even larger telescope, which was going to be called OWL, standing for the Overwhelmingly Large Telescope. Now, unfortunately, this idea of a 100-metre diameter mirror was just too big to be built. And so they scaled back, and the telescope currently under construction that the astronomy community is very excited about is the ELT, just the Extremely Large Telescope.
Inside this telescope, there is a mirror made of a very special kind of glass, with a diameter of 39 metres. It's so large that if you laid it on a football field, it would touch the outer edges. A giant mirror with a perfect location. The Atacama Desert in Chile is a place where there is little atmospheric disturbance and no artificial light. To produce the best images, the mirror's glass mustn't move a millimetre and has to be absolutely heat resistant. That's why it will see 8 million times more light than Galileo's telescope. And that means not only creating much sharper images, but also looking further into the universe than ever before. Even though glass is structurally problematic.
Glass still puzzles us. You might think, yeah, it's a solid, right? Well, actually, there are people thinking that glass does flow on incredibly long timescales. We don't quite understand the atomic structure of glass, and it's something that we're still researching into today.
The story of the invention of this special kind of glass begins in the 1960s as the Cold War reaches its peak. It's precisely at this time that a series of experiments on glass ceramics begins in Germany.
In 1964, household crockery was to be made from a white glass ceramic. In the end, however, we had to knock the crystallized mass out of the tub with a pickaxe.
The accident is expensive. The research is stopped and banned. But because the material is so fascinating, with the same heat resistance as ceramics, Dr. Jürgen Petzold continues to research in his spare time.
My boss at the time, who was also interested in the product, was also interested in the material. He said that we can't actually do that, and then he had the great idea that we could do some research in the field of glass ceramics, with the ulterior motive of being able to present a result to our company boss, Eric Schott, on his 75th birthday, hoping that he'd be happy about it and not kick us out.
Dr. Jürgen Petzold is not fired, even though no one at the time had any idea how glass ceramics would change the world. As Serradura, the mirror for the telescope, it sharpens the view of the universe, and as Ceran, probably the best-known glass ceramic, it has revolutionized the kitchen.
Recipes for ceramic glass are closely guarded secrets. They're basically the same ingredients: sand, chalk, soda. But there are so many variables that make a different end product. The temperature, the method of cooling, the addition of tiny amounts of different chemicals that change the properties of the end result. The possibilities are almost infinite.
The secrets of how Serradura is made for the extremely large telescope are also closely guarded. But we do know this much. The glass is heated to over 1600 degrees Celsius. poured into a mold, cooled to room temperature, heated again to 800 degrees centigrade, and polished after cooling.
It's an incredibly elaborate process, but the end result will be to see the mysteries of deep space with even greater clarity than before. That's a price worth paying.
The giant mirror has a total of 798 parts, which are all individually processed. Only after completion are the parts transported from Europe to Chile and assembled. The special thing about glass ceramic, it doesn't expand at all. So, no matter whether it's hot or cold, the glass doesn't move a single millimeter. For this reason alone, it produces images 15 times sharper than the Hubble telescope. It can be used to study planets and stars, to make unexpected discoveries. Might we gain new insights into the origin of the universe with it?
Astronomers could be able to find Earth-like planets orbiting other stars. They could even find evidence for water, which could mean life outside our solar system. This is an incredible opportunity. Galileo's already massive mind would have been blown.
During Galileo Galilei's lifetime, glass was something special, unique, and extremely expensive. At that time, the center of glass production is here in Venice. The glassblower's knowledge is so precious that it is protected with harsh methods. As far back as the 10th century, glass is already being produced in Venice. It becomes the birthplace of many inventions and a center for the best glassblowers in the world. At the end of the 13th century, production is relocated.
The city of Venice moved glass production out to the island of Murano, not just because it reduced the risk of fire in the city, but also meant that they could keep tighter control over their glass makers and the secrets that they held.
In the Middle Ages, the Republic of Venice is rich and powerful. Its glass products are exported all over the world. To protect their secrets, the Venetians have come up with lots of ideas.
The master glassblowers had an important beneficiary role for the Serenissima Republic and became noble by title due to the importance of their profession. As a noble, he did not have to pay any tax. His knowledge and culture were an advantage for the Republic. Terms existed, and without doubt, they could not work with glass everywhere.
To prevent the secrets from being revealed, there is the threat of the death penalty. That was about 500 years ago, and long after glass has to overcome its first crisis.
We know that glass has been produced in Egypt since 1500 BC. We know too that the Romans developed a particular demand for glass produced in Egypt, in Alexandria in particular, and huge numbers of items made their way from Alexandria, yes, to Rome, but also outside the Roman Empire. A glass bowl made in Alexandria has been found in Afghanistan, for example.
In Syria, glassmaker's pipe was invented as early as the 1st century before Christ. But around the time of the birth of Christ, the center of glass production shifted to the Roman Empire. Finds from Pompeii and Herculaneum show that the Romans were already able to produce transparent window glass. But this glass was about as expensive and valuable as gold.
So there was a huge amount of knowledge that was accrued about how to make glass and even make windows and everything like that. But unfortunately, a lot of that knowledge, it was lost.
The fall of the Roman Empire set glass production back centuries. Until this knowledge is rediscovered, almost 1,000 years pass. In the 15th century, the next chapter in the history of window glass is written in Murano. Here, the glassblowers rediscover and perfect the lost knowledge. This black, metallic shining powder changes the color of glass. It is pyrolusite, or manganese dioxide, which is found all over the world. Finally, glass can be made almost colorless again.
It's amazing. Just by adding manganese dioxide, it completely changes the properties of glass, making it transparent. Wow.
A particularly clear glass is called cristallo, crystal glass. This is an incredible step forward for the time. Some sources say this invention is attributed to the Venetian Angelo Barovia in the 15th century. But the coveted colourless material is in use by the year 1300 at the latest. 400 years later, Murano glass is still unique. But with the Industrial Revolution, glass is completely reinvented. The 19th century, a time of progress and inventions. Factories are built and many people move to cities.
The Industrial Revolution utterly changed the world in the developed countries, and one of those was Germany.
This is where the young Otto Schott lives, and he will be responsible for an incredible invention. Schott researches glass scientifically, with precision and patience. No one has ever done it like this before. With an almost infinite number of test series, he wants to find out whether the optical properties of glass can be precisely defined in advance.
Otto Schott got in touch with Carl Zeiss and Ernst Abbe, who had a production plant making microscope lenses in Germany. Now, they were creating okay lenses, but through trial and error. They really didn't know what they were doing on a scientific level. Otto Schott wanted to help.
And eventually, he succeeds in precisely defining the optical properties. First, with phosphorus oxide, then with lithium, but the quality was insufficient. The first samples contained streaks and bubbles and are not suitable for microscopes. His idea? To stir the hot glass mass with Dutch tobacco pipes made of fire clay. And it works. This new optical glass is completely pure and, in 1884, it revolutionizes microscopy.
After all this success, Abbe, Schott and Zeiss founded the glass technical laboratory called Schott and Comrades. Later on, Schott's glass would be taken to the moon and used to film the first steps of humans on our nearest satellites.
But Schott's inventive spirit is far from exhausted. His next invention aims to solve a crucial problem with glass.
Glass is brittle. It's a material which does not cope very well with sudden mechanical shocks, but also sudden thermal shocks. If you take a Bunsen burner and you put it against a piece of conventional glass, even a wine glass, it will shatter in an instant.
This happens in 1891. Schott's second son, Erich, is being baptized when a gaslight is lit in the cold church. It breaks, and this is a key moment for his second invention.
As a scientist and as a human, I know what Schott must have felt. He desperately wanted to fix this problem. It must be solvable.
Schott starts another series of tests. This time, however, he not only solves a problem, but also enables scientists to work in a new, insightful way.
Glass has been absolutely central to the chemical enterprise, really since probably the 16th, 17th centuries. Before that, alchemists worked often in ceramic containers. And yet, the ability to use glass to be able to see what was going on inside was absolutely crucial.
Schott solves the problem of fragile glass. His invention? Borosilicate glass. It withstands temperature differences, acidity, and extreme heat.
Borosilicate glass has caused a revolution everywhere from chemistry to the kitchen. That's because it's got two key advantages over other kinds of glass. Firstly, it doesn't expand very much when you heat it up. That means you can take a borosilicate glass oven dish, for example, you can put some food in it, stick it in the oven, and even as it heats up, because it will expand by such a small amount, it won't expand so much it cracks. The other place this is really useful is in the chemistry lab, because you can put some chemicals into a test tube, for example. You can stick them over a Bunsen burner, and even though there's literally fire on one side and there's a cool chemical on the other, the expansion is sufficiently small that the test tube won't crack.
At last, scientists can observe chemical reactions without putting themselves in danger. A considerable advance on the clay vessels and fragile glass of the late Middle Ages. But glass history is also being rewritten in the Middle Ages, albeit in a completely different way. Between the 13th and 16th centuries, windows are objects of art, especially in churches. But then architecture begins to change.
During that Gothic period is that suddenly the availability of light, an architecture which allows light into the building, made such a difference to the emotional state, the feelings of the people.
Light, a central theme of this time. Along with the knowledge of structural engineering, the invention of the lead glass window is also decisive. Individual small glass panes are joined together by lead. The technique of producing flat glass for larger window panes does not yet exist.
It would be wrong to think that in the Middle Ages, people didn't have the knowledge to produce glass or didn't use glass in windows. Any visitor to a medieval cathedral can see these glorious stained glass windows. The issue was more one of cost. Glass was expensive to produce, it also broke easily, so it was expensive to replace. In buildings such as cathedrals, where cost was often less of an issue, installing glass was no problem.
Then the cost changes. Thanks to a new process to make flat glass, windows become cheaper. The place of this invention? Murano.
One of the first types of window glass was called crown glass. And the way that was made is that a glass blower would blow a spherical ball of glass and then place that onto something called a punty. And keeping it warm and spinning this punty around, centrifugal force would cause the sphere to unfurl into a flat sheet with the thinnest, best quality glass around the edge.
These glass discs have been produced since the 13th century. However, the craftsmanship and the manufacturing process varies depending on the country and craftspeople. The fact is that by working with the glassmaker's pipe, glass panes can be produced faster and with less effort. These bottle glass panes continue to be produced until the second half of the 20th century.
Another discovery makes glass even cheaper. It's potash. It can replace the very expensive imported soda in the production of glass. But although there's a lot of potash around right now, it's not going to last forever.
The end of the 18th century, it's the time of Napoleon Bonaparte, and an epoch in which glass production is facing a new challenge. Napoleon revolutionizes Europe by armed force, and this is one reason why glass is becoming more expensive.
Napoleon's demand for potash to be used in gunpowder was so great that little, if any, was left in civil society for the production of glass, leading to what historians have called the glass crisis in Europe.
1,000 kilograms of wood has to be burnt to make 1 kilogram of potash. Demand is increasing, resources are becoming scarce, and potash is costing more and more, a big problem for glassblowers and the buyers.
Potash became so expensive at the time that ash collectors go from house to house to try and get their hands on the stuff.
Only after 100 years, when Napoleon is already a figure of history, is the potash problem solved. At first, potash has replaced the salt mineral soda, which is expensive to mine and import. Attempts are now being made to produce soda artificially, way back in 1775. But it was not until 1863 that the new process achieves a breakthrough. The Solvay process, developed by the Belgian Ernest Solvay. For his soda, he only needs cheap table salt and lime, an incredible innovation not only for glass production. Soda is also urgently needed for soaps, detergents, in the paper industry, and of course, for baking and cleaning. Without this artificial soda, glass would never have become what it is today. And an invention from the 1970s that changed our lives massively would have probably never been possible. The 1960s and 70s. The world is growing closer.
Around this time was when huge developments were happening in terms of sort of live TV and communications, trying to send that all around the world. And that comes with real demands on how much data you can send and how quickly you can send it.
An almost impossible task. But that's what they thought about the moon landing.
The Eagle has landed.
Send ever more data, even faster. In Germany, Albert Einstein sets a milestone for the solution as early as 1917.
Einstein, the famous theoretical physicist, proposed in 1917 that a laser could be built to create a coherent beam of photons, an incredibly powerful light source that could travel for a huge distance. But it took another 50 years for physicist Theodore Maiman to actually make one.
The American Theodore Maiman is an engineer, physicist, and the son of an inventor.
He used incredibly bright lights to stimulate a crystal of ruby, and that produced laser light at 694 nanometers, a very deep shade of red, for the very first time.
The invention of the laser combined with the invention of optical fibers to create this new communication tool. Incredibly strong light could be used to code information and send it down these tiny fibers enormous distances. This information could travel across the world, or it could if it actually worked.
The problem? Data loss. USA, Europe, Japan, and Australia. Research is carried out on the combination of laser light and fiber optics, but no one succeeds in solving a decisive problem, receiving data exactly as it is sent.
There was a serious challenge when this was first being developed. A lot of light seemed to be being lost, and scientists all around the world are trying to work out how to optimize the production of the glass in order to reduce these losses.
1970, 3 American scientists succeed in inventing the first fiber optic cable that transmits without any data loss. They are Dr. Robert Maurer, Dr. Peter Schultz, and Dr. Donald Keck. 18 years later, the cable ship Longlines connects the USA with France and Great Britain with fiber optics for the first time.
Once again, the Bell Systems ocean cable layer CS Longlines moves up Chesapeake Bay toward Baltimore.
The first transatlantic fiber optic cable is laid.
On December the 14th, 1988, finally, the first transatlantic fiber optic cable is brought online. The T8 is still operational in 2002, creating communication across the Atlantic Ocean.
Today, fiber optic cables connect continents, countries, and cities. And data transfer is getting faster and faster. While TAT8 transmitted around 560 megabytes per second, today's cables can handle 100 terabytes per second. That's as much as 71 million HD videos being played simultaneously.
The explosion of fiber optic cables comes at exactly the right time, because this is the birth of the internet. Without fiber optic communication, the internet would never have developed out of its little tiny nursery stage. It would just be something academics use to communicate scientific results to each other. It wouldn't have become the enormous phenomenon now that influences every part of our lives.
The internet is a life-changing invention made possible by glass. Large glass windows that protect from the weather, but let in light is another. It all begins with mirrors. France, around 400 years ago. It is time for the next chapter of window glass invention, in which one man plays an especially important role.
The court of Louis XIV was all about extravagance and making everything look as shiny or sparkly as possible. And he's called the Sun King because of his love of gold and things associated with that.
Louis was a king who believed absolutely in his divine right to rule. Nowhere do we see this perhaps better manifested than at the Palace of Versailles.
And the highlight of his pompousness, a room full of mirrors. It could hardly have been more expensive, more noble, or more extravagant. But the knowledge of how to produce high-quality mirrors lies solely with the glassblowers in Murano. One of these skilled families is called Barbini. The family still produces mirrors today.
Our family's been present in Murano since the mid-16th century. They worked in every field within glassmaking: artistic glass, beads, chandeliers, and then specialized in mirror making.
The Sun King wants these Venetian mirrors at all costs, but not at the expensive price the Italian monopoly demands. So he instructs his Minister of Economics to find a solution. In a secret cloak and dagger operation, he sails to Murano and convinces mirror makers to come to France to work for the king. Industrial espionage of the 17th century. It is said that a total of 18 glassmakers make the journey to France. One of these poached mirror makers is Girolamo Barbini, an ancestor of Pietro Barbini.
In 1665, he and his two younger brothers, together with other glassmakers, left for France in secrecy to start out an activity of Venetian mirror making under the reign of the King of France.
In 1688, the French not only uncovered the secret of mirrors, but also invented an effective rolling process for producing flat glass.
The French technique made it possible to make larger mirrors compared to the ones obtained via the barrel-blown bladders made in Murano. In France, the so-called pouring technique, colatura, resulted in pouring a larger amount of glass, and therefore the final result was larger mirrors.
The Hall of Mirrors in the Palace of Versailles is therefore not only a testimony to this incredible time, but also a story of espionage and betrayal. Today, industrial espionage has reached a completely different level, and a new invention ensures that corporations, like the Sun King once did, are also able to draw on insider knowledge. The 21st century. For a long time now, making simple glass windows has not been a problem. It is the age of communication and information, and completely different issues come to the fore. Glass, the material of the present. We use it all the time, sometimes without even realizing it, until it breaks.
Cell phones have glass displays, which of course makes them vulnerable, but plenty of companies are trying to solve this problem.
One solution is armored glass, a glass that is also used in the military. It's almost indestructible. But there are other approaches to solving the problem.
Corning in the USA invented Gorilla Glass, which is so tough that it won't break even when hit by a hammer. And that's because of their special chemical recipe and their extremely secretive heating and cooling process. I will not be demonstrating it with my own cell phone.
Research on glass as a material of the future is also being carried out in the town of Grunenplan in Germany's Lower Saxony. But the solution here lies in the thickness. This is where the thinnest glass in the world is produced. It's flexible and break-resistant. It's only 25 microns thin. In comparison, a human hair is twice as thick.
I mean, it almost beggars belief that you can make glass sheets this thin, ultra thin, thinner than a human hair, and have it be flexible without breaking. I mean, with that, it's going to come huge numbers of potential developments in their usage in, particularly technology.
Of course, the recipe for the glass is secret, but we do know a few facts about the process. The recycling aspect is also an important factor. It saves costs and resources, and nothing goes to waste.
Our ultra-thin glass also has all the advantages that normal glass has over plastics. That's what makes it so interesting, because it is also flexible, foldable, and hardened, so it is not susceptible to scratches or impact.
The technology behind this is called the down-draw process. That is to say, a process that draws glass downwards, and it goes like this. The hot glass mass is drained through a funnel. The glass runs down through several rollers and gets thinner and thinner. Then the hot glass is cooled and rolled again. This is how this ultra-thin glass is made. It's so flexible that it can even be rolled up.
Our ultra-thin glass is used in many areas. For example, in the field of consumer electronics, smartwatches and smartphones. In the future, it will be used with foldable displays. At the moment, it is also used for camera sensors, camera systems, optical components, and as a cover for fingerprint sensors.
The idea of a glass sheet printed with microelectronics and folded up seems space age, but it's already here. You can get cell phones that fold up flexibly already. That is just mind-blowing.
Equally mind-blowing is an invention from the time of the Industrial Revolution, because it saves lives.
The Industrial Revolution was changing the world, but with those changes came problems. The invention of the car, fraught with difficulties, particularly when it came to windscreens.
The world around 1900. Roads are no longer used by slow horse-drawn carriages alone, but increasingly by much faster cars. However, the blast of the wind becomes unpleasant. Windscreens are invented.
Glass was actually one of the most dangerous materials at that time because it was being used to make windscreens. And in car accidents, the windscreens would shatter, making huge shards of glass, which is obviously very sharp and very dangerous.
A braking test at a scrapyard. Simple window glass, like the windscreens of the early days. The shards, large, sharp, and pointed. The risk of injury, enormous. This is a real problem for motorists around 1920. Without knowing it, the Frenchman Edouard Benedictus solved this problem, in fact, years earlier.
He was messing around in his lab one day and knocked a glass flask onto the floor. But instead of shattering into hundreds of pieces, it stayed pretty much intact. When he investigated afterwards, he discovered that the flask had contained a plastic, a liquid plastic called cellulose nitrate. And as the plastic had evaporated away, it had left a thin film of solid cellulose all around the inside of the flask, which is what was holding it together when it hit the floor.
Another test at a scrapyard. This second braking test does indeed show. There is a hole in the windscreen, but around it, the fragments stick together. They're also very small and have no sharp edges. This greatly reduces the risk of injury. Benedictus's triplex glass causes a worldwide sensation. It revolutionizes not only the automobile industry, but also the war industry and architecture. The principle of laminated glass is still similar today. Put simply, 2 or more panes are covered in an adhesive layer of plastic and then pressed together. But today, laminated glass has to withstand much, much more. Especially in architecture, skyscrapers are getting higher. The dangers more extreme. Glass buildings have to withstand nature's mighty forces. whether in Asia or in the United States. Typhoons, hurricanes, or cyclones, extremely high wind speeds can generate enormous forces.
I mean, I guess we take it for granted that just behind this glass that we are perfectly safe, but look at how much has to go into it to make it safe for us.
In Grundelfingen, Bavaria, there is a special test site for glass facades. Here, the fragile material is really put through its paces. Installed in a frame, the window glass is thoroughly tested according to where it is to be used.
In Hong Kong or China or in the Asian area, there are mainly typhoons. The wind loads are very, very high. In San Francisco, for example, where we also build a relatively large amount, the movement of the building shell due to earthquakes is very high. This has to be considered in the construction, in the way we position the glass. It has to be able to meet these requirements.
Everything has been calculated, but now it's time for the test. Will it be able to meet all of the requirements? Test 1, rain. Test 2, wind. Test 3, tensile force. Test 4, impact. Test 1 begins. Although the air temperature is icy and some of the water freezes, there is no problem for the glass. More than 3 liters per square meter per minute are sprayed at the window. The facade remains watertight. For the second test, a huge propeller is placed in front of the structure. With a wind speed of 110 kilometers an hour, the laminated glass has to withstand the force and not give way 1 single centimeter. In general, wind is always a problem with high-rise buildings, because at height, where the tops of the buildings are, the wind is always stronger than on the ground. The pushing and pulling produces swinging motions, which have to be balanced structurally. Back to the test. This step has also been successfully completed.
The facade tests are not only important, but actually very interesting. Because our structural engineers, or our engineers who try to conceive this facade theoretically, can also use the facade tests to check whether their calculations are correct.
For test 3, a pulley is fixed to the facade. Why is that important? The only problem that glass experts have not yet been able to solve is self-cleaning. Gondolas exert a strong pulling force on the facade, and this has to be tested. Window cleaners' lives depend on it. In order to generate real conditions, 107 kilograms are suspended from the facade using a cable winch. The test is successful, and it's becoming dark. The team quickly sets up the construction for the last test. This time, a 50-kilogram bag filled with tiny glass beads is going to bash against the pane with great force. It simulates, for example, a large bird or a human being bouncing against the window pane. So what happens to the glass with this kind of impact?
I mean, you could see the glass sort of flexing and bending and it wasn't cracking. That's amazing.
The glass meets all the requirements, unlike the sack. Glass is obviously an opponent not to be underestimated. Architects and engineers can look forward to the future, because glass, although brittle, can now do almost anything.
The panes are getting bigger and bigger. The quality of the glass is getting better and better. We're getting curved glass in a different or better quality, so of course architecture has more freedom and can build crazier things. We've got some stuff on the radar right now that looks really great, so we can look forward to that.
Architecture's limits are being pushed ever further. It seems like anything is possible. But it's been a long journey to get to this point. In Europe, the years following World War II look quite different. Cities have to be rebuilt. Food is rationed. A time of having to do without. It's not until the mid-50s that the biggest crisis is overcome and people begin to think about the future. Windows are now being produced in large quantities and at low cost, making them affordable for everyone. But with luxury comes a first world problem. The glass panes distort the view to the outside.
It looks like a liquid in which everything has been stopped, and nothing has had time to choose the perfect optimum arrangement, right? Which is what you get in a crystal. In a crystal, everything is arranged in neat rows and neat lines, and there is a structure. The thing about a glossy material is that it's kind of random. And that's the secret to its properties.
An engineer and war veteran from England, Sir Alistair Pilkington, is to solve the problem of the view-distorting panes and has a groundbreaking idea.
Pilkington discovered that you can float molten glass on a layer of liquid tin. Because the liquid tin is more dense than the molten glass, the glass floats on top, spreading out to create a perfectly flat, even, transparent surface. If you cool that glass, it can then be turned into windows, doors, anything you like.
Many liquids mix together, but some don't, because their density is different, such as vinegar and oil. The same is true for liquid tin and glass, and this is the principle of the float process. After the glass is heated to around 1,300 Celsius, it flows onto a tin bath. In the tin bath, the size and thickness of the glass can be variably defined. Over a length of around 240 meters, the glass is slowly cooled. When brought to room temperature, the glass is evenly flat. Finally, the glass pane is simply cut to size, making glass windows and doors for our houses and buildings.
So at last, we have glass that's homogeneous, nice and even, and you can actually see the real world on the other side, that it's not distorted. And this process means that we can make huge sheets of glass now, up to 20 meters wide.
To fill the holes in the walls with glass, lots of problems had to be solved. But today, not only can huge panes of glass be produced, they can also be made into safe window glass using a special process. The current world's largest window pane is 20 by 3 meters large, made in Germany. 4,000 years of glass history. It's an incredible material. It's transparent, almost non-existent, and yet it protects us. It's thinner than a human hair and can't break. It's art and science. It can unite continents and is a component of energy production. And one of the biggest benefits in recent history. It's sustainable and recyclable. But what might happen next? Some ideas may seem utopian, but they could solve problems that we don't even know exist. Glass in the form of an intelligent plaster could scan injuries and help us to heal faster. Or, and this is no longer a utopian vision, mix our real world with the virtual world. With augmented reality, AR for short, we can better understand interconnections. Until now, it was only possible to switch from reality to a virtual space. But mixing them like this opens up many new possibilities. But what role does glass play here? The spectacle not only consists of a highly complex computer, but also of special lenses that have to be manufactured with absolute precision and, above all, have to be 100% flat. A real challenge for engineers. With this glass technology, we can suddenly perceive reality in a completely different way. We receive information about everything that interests us. We can put things together or take them apart without destroying them. But this is by no means the end of glass's development. Thanks to glass, we're looking deeper into the universe than ever before.
It's actually amazing to think that glass played such a fundamental role in our understanding of our solar system.
Glass has revolutionized the way we live.
I think it's almost impossible to imagine what it was like before glass was invented.
Glass enables us to share thoughts at the speed of light.
Glass still is a mysterious substance, even with the long history of our usage of it, but it's been so versatile and we're pushing the boundaries of what's possible to do with it today.
What will the future of glass research hold in store for us?
Among every other profession in the world, glass is one of the most difficult arts to deal with. Why? It would require 4 lives in order to understand something about glass.
From a simple, dull material to the science fiction substance of the future.
All of this is because of glass. Where would we be without this miracle material?
Year for year, billions of cans roll off production lines all over the world. Cans continue to be very popular with many grocery shoppers, and food manufacturers prize the can's lightweight and durable material.
They're so great because they're light and robust and so perfect for transportation.
Cans are packaging and container in one. This advantage makes them very convenient on the road and at festivals.
Certainly remember when going camping on hikes, having pre-made chili in a tin was the way to go. And who's got time to actually pour that out? No, eat it straight from the tin.
From tomato sauce to burgers, cans promise a decades-long shelf life.
German pensioner opened up his garage in 2002 and found a collection of canned goods which had been sitting there for 4 decades, and decided that he should give these to the local museum.
Apparently, the bread was still edible, according to the museum director. We take it for granted that food products now have a shelf life of not just weeks, but years. Not so long ago, however, an invention like the can was still an elusive dream. In the mid-18th century, famines threatened the lives of people across Europe. Long, hard winters, but also pests, caused crop failures. This problem plagued populations for many decades. And the struggle continued in storehouses, against foraging animals such as mice and insects, but also against time, the natural enemy of perishable foods. Most of the techniques used to preserve food had already been known for thousands of years.
When we learned how to control fire, we also discovered that smoking made meat last longer. Smoking was probably the oldest method of preservation. Drying was also really popular with Egyptians because of the hot climate.
Drying as a preservation method also goes back a very long time in the northern regions. It's how Norway's famous stockfish is prepared. Originally a poor man's food because cod was so plentiful, stockfish also became a seafarer's staple. Babylonians and Sumerians traded in salted meats. Salting is an ancient food preservation technique that's still in use today. Similarly, cheese making is a technique to preserve milk. Once the milk is heated to the right temperature, rennet, a calf's stomach enzyme combined with bacteria, is added. Then you have to wait and stir it again and again until you get cheese. Depending on the cultural milieu, macerating in oil, vinegar, or alcohol were also common preservation methods.
When I I think of preserving food, I think of pickling something, for example, gherkins or onions or eggs.
While all these techniques worked, they did so for a limited time only, and when overdone, some of them could even result in toxic foods. Already in ancient Greece, people used sulfur to preserve wine. Sulfur reacts with oxygen and prevents the wine from oxidizing and turning into vinegar. But this was not without risk.
When people started realizing that sulfurized wine could actually poison you, sulfurization was banned in some countries. The Roman-German Emperor Maximilian I permitted sulfurization again, but only with strict adherence to a maximum value. Violators were punished.
The European Union currently regulates the use of about 60 food preservatives, including sulfur and sulfur dioxide. Over many centuries, preservation methods hardly changed at all. In the 18th century, however, food products were subjected to stricter requirements. The time was ripe for a new preservation technique. A revolutionary invention that takes our domestic storage cupboards by storm. A milestone in the history of conservation technology that inspires young and old, but also four-legged friends, and continues to do so today. In 18th century Europe, death by starvation was an omnipresent threat to the population, but also to the military, on land and at sea. During the 7 Years' War in the 1750s, for example, half of all the British sailors involved died of malnutrition.
At sea, it was common at the time to eat salted meat and hardtack biscuits, which is a kind of biscuit made from flour, water, and sometimes salt. Everything else was too perishable.
After the French Revolution in 1789, hundreds of thousands of soldiers were engaged in fighting each other across Europe. Armies of this size were a new phenomenon.
An age-old solution to the problem of feeding the army is just to loot the lands that you're travelling through. And they do that. But the scale of the army is such that it's becoming impossible to find enough food. And so somebody has to find a solution.
How can I get my soldiers fed? This question also troubled the notorious general Napoleon Bonaparte. After all, his men should be able to defeat the enemy.
So in 1795, Napoleon looks out at his army and he finds a group of men who have been decimated, not in war, but through hunger. And so what Napoleon does is to launch a competition. He wants to find a new way of preserving food, and so the winner of that competition will receive 12,000 gold francs.
The war and the advertised reward ignited innovation and inspired the imagination of numerous inventors, including the Parisian confectioner Nicolas Appert.
Nicolas Appert was also a trained master chef and took on Napoleon's challenge. Appert set up a workshop and started testing different methods, but he was never quite satisfied with the result.
They either didn't please the chef's palate, or they literally blew up in his face.
In Appert's search for a method, he came across research results from the Italian clergyman and professor Lazzaro Spallanzani.
Some 40 years earlier, Spallanzani had already proved that the growth of microorganisms in food could be prevented by heating an airtight sealing.
One of the most famous bacteria that affect millions of people annually, sometimes with severe and even fatal outcomes, is Salmonella. Symptoms are fever, headache, nausea, vomiting, abdominal pain, and diarrhea.
Appert was convinced that Spallanzani had been on the right track. Heating was the solution. He filled glass bottles with meat, fruit, and vegetables, sealed them airtight with corks, and heated them in a water bath. He spent years tinkering with the temperature and cooking times.
The French Navy tested Appert's invention. During long and stormy sea voyages, some of the glass preserves broke, but the food in the containers that remained was still intact and edible. This was a great success for Appert and made him the official winner of Napoleon Bonaparte's competition.
In 1810, Appert was awarded the prize money of 12,000 gold francs, along with the French honorary title Benefactor of Humanity. He had invented a food sterilization technique.
But glass is quite heavy and breaks easily, which is why not only inventors, but also businessmen kept looking out for an even better solution.
Philippe de Girard, an engineer, experimented with metal vessels and invented the world's first tin can.
So the history books usually say that the man who invented the tin can was a British businessman called Peter Durand. And he was the man who in 1810 patented the tin can procedure. And so he is seen as the man who invented the tin can. But if one looks at the patent, what you'll see is that he notes that this was an idea that was given to him by a certain foreigner.
De Girard had sold his idea, and with it also his rightful place in the history books, as the inventor of the can.
A short time later, the world's first commercial cannery opened, Donkin's factory on Southwark Park Road in London. Around 1813, they started producing canned food for the Royal Navy.
Among the first people to get to taste canned veal roast was Queen Charlotte and her husband King George III. Both of them approved of the canned meat's taste.
I don't think I'd want to be the first person who tries the world's first ever stash of canned meat. To be honest, it sounds unappetizing.
Oh, I'd have been thrilled to have tried the first canned meat that was produced. It was good enough for George III, who has canned meat in 1813. It's good enough for me.
Nicolas Appert, the inventor of thermal sterilization, welcomed the advancements made to improve his method. He started his own cannery with the prize money from Napoleon.
So one of the great events of the Great Exhibition in 1851 was the opening of a can of food. It had been canned 38 years before by Nicolas Appert, who in fact had died in the intervening period. And so his can of food had outlived him.
Fueled by industrialization, canned food became a smash hit. Canneries popped up like weeds throughout Europe and the US. All the branches of the armed forces were eager to benefit from this invention. It would take some time, however, before cans found their way into private households. Many of us grew up with canned food as a normal part of our lives, and we can all think of different canned classics from our childhood days.
As a kid, baked beans on toast was an absolute treat, and to this day, still something of a comfort food.
One I remember best is haggis. I come from a Scottish family, and haggis is a typically Scottish dish. It's offal from sheep mixed up and served ideally in the sheep's stomach.
As a child, what I used to eat out of a tin can was corned beef. I absolutely loved corned beef sandwiches with tomatoes, and even though they ended up soggy by lunchtime, they were just perfect.
Another pantry staple of undisputed renown is canned sardines. As early as 1895, a California man named Frank E. Booth began packing sardines preserved in oil into cans. Thanks to inexpensive raw materials, good storage ability, and high nutritional value, canned sardines were used as provisions for troops in numerous wars. But in peacetime too, they were a much in demand and inexpensive source of nutrition, all over the world. The sardines used for canning increasingly came from African countries, such as Morocco, and continue to do so. Moroccan sardines are considered a delicacy. They are shipped all over the world. Another world-famous canned classic, one that especially Italians can't do without, is tomatoes.
I use canned tomatoes in pretty much every dish I know how to cook, but the first one I learned was bolognese, and canned tomatoes are essential in that.
I use them to make pizza, and I use them to make pasta, and yesterday I used them with my children to make chili con carne. So they're everywhere. They're always in our kitchen.
In fact, tomatoes are one of the things that often even tastes better canned than fresh, especially when peak season is over and only pale, hard varieties are available in grocery stores. The canning tomato harvest takes place here in northern Italy, in one of the largest tomato growing areas during the summer. This region has a particularly favorable climate, with ideal conditions in terms of temperature and humidity. A few kilometers away, the humidity is already too high and makes tomatoes more susceptible to fungal diseases. Tomato farmers here can expect to harvest up to 200,000 kilos of tomatoes a day. Modern harvesting machines make it possible. This tomato variety is specially bred for mechanical harvesting. It's smaller, more robust, and has thicker skin than other varieties. The distance between the field and the cannery is short. Canning tomatoes must be processed as fresh as possible. Green tomatoes are sorted out by hand. The others are subsequently processed in a fully automatic peeling machine. Post-peeling, a sorting machine removes the broken fruit. Only intact specimens make it into the can as whole tomatoes. The rejected ones aren't thrown away, but end up as canned tomato sauce or passata. Just as a can's content is variable, the can itself has also assumed various shapes over time. And of course, can production technology is also continuously upgraded. Unknown to manufacturers and consumers of the time, the early cans contained toxic substances. The reenacted scene shows that the production of cans used to entail demanding manual work, which made them expensive. Too expensive, in fact, for most people.
£8 for a can of carrots. Sounds steep today, but it was horrendously expensive for people back in 1813. Just imagine, that's about the amount of money a head housekeeper would earn per year at the time. Canned food was just way too expensive for civilians. Among the few who could afford it were, of course, the military, and particularly in the case of famous Canadian polar explorer Sir John Franklin.
In 1845, Franklin's vision was to sail through the Northwest Passage, heading east to west for the first time. He set sail with 2 ships, but he never returned. Franklin's distraught wife had 5 ships dispatched to search for him.
The Franklin expedition had just about everything you might want in it to make it a sensational story. It had a sort of noble hero, it had a grieving widow, and more than rumours about the existence of cannibalism.
It wasn't until 14 years later that the first remains were discovered. It was determined that chronic lead poisoning led to their deaths. Lead-soldered cans, typical of the time, were deemed the most likely culprit.
Today, scientists assume that the cans were not the sole reason for the death of the team. The amount of lead was just too small to be fatal. A variety of unfortunate circumstances are more likely to have caused the mission to fail. According to one theory, the 2 ships got stuck in the ice. Since the team did not have enough food for such a long period, the men probably died of malnutrition and scurvy.
The theory that the explorers fell victim to lead poisoning was a PR disaster for the 19th century canning industry. Manufacturers had to upgrade the canneries and find new solutions. From 1875 onwards, seamed cans and can seaming machines rendered soldering with lead obsolete. This X-ray image shows how cans are closed nowadays by interlocking the lid edge with the flange of the can body. Ongoing advancements in closure technology made the production of canned food less and less expensive. By 1900, cans were finally also embraced by the masses. In the US alone, about 700 million cans were produced that year. They are a runaway bestseller for many decades. Modern-day can factories can churn out around 9 million cans every day.
First, square plates of sheet metal are coated on one side with white or golden paint. The wafer-thin but highly elastic inner coating prevents possible chemical reactions between the food and the metal surface.
Then the sheet metal is cut to the dimensions of the can and bent into a cylinder. The two ends of the metal strip are welded together.
The cylinder is not yet particularly stable at this stage, which is why the next step is to fine-tune the surface structure. First, the edges at the top and bottom are pressed in a little, then bent outwards. Then the body gets its typical grooves, which gives it stability.
The round can bottom is put atop the cylinder and the two sheet metal sections are rolled into each other. The can is now leak-proof and ready to be filled. This step has long since been automated. These cans are being filled with the popular treat, baked beans. All that's missing now is the lid. As with the can base, the lid is pressed together with the can body. The can is now sealed.
In the last step, just like its historical precursors, the filled can is then boiled in a large kettle, and only after this final step, the canned foods are preserved.
These days, unsurprisingly, we use a can opener to open cans. But at the beginning of the tin can era, this device had not yet been invented. Napoleonic troops had to stab through their cans with a bayonet. Elsewhere, soldiers used hammers and chisels, or axes. A can opener, as we know it today, would not even have worked on these early cans.
The material was still too thick. Early cans were made of wrought iron and were lined with tin on the inside. This meant the can walls were up to 5 millimeters thick. Hammer and chisel were not a stopgap, but the manufacturer's actual recommendation on how to open it.
It took advancements in tin plate production for the can walls to gradually become thinner. Tin plate has always been made of steel. The steel slab was originally hot rolled into thin strips. The resulting sheets had a thickness of several millimeters. It took another invention, namely cold rolling, to finally get even thinner sheets.
After the steel has been hot rolled, it's then cold rolled. This step usually takes place at room temperature without the steel having to be heated again. Cold rolling reduces its thickness by about 90%.
Thanks to this new rolling technology, today's tin plate is now only 0.12 to 0.24 millimeters thick. The advent of thinner-walled cans in the mid-19th century necessitated a new, more sophisticated can opening method that didn't endanger the can's integrity. In 1858, Ezra J. Warner, an American, applied for a patent for the first can opener, almost 50 years after the tin can was invented.
Ezra J. Warner's tin opener was a large blade to cut through and into the can, but critically, it had a device which was designed to protect the contents of the can.
Warner's invention was mainly used by soldiers during the American Civil War.
It was simply too dangerous to use at home. And so what people would do is buy their can or bring their can to the grocery store, get the shopkeeper to use the Warner device, and then they would take their can home to cook it.
After Warner's invention, 10 years passed before another American patented the pioneer of today's standard openers. The basic mechanism has remained the same until today.
William Lyman is considered the rotary cutter's inventor. His opener was, however, still missing the gear crank. Over the course of time, new can opener variations emerged. Sometimes their use was intuitive. Some required more, some required less muscle power. In the end, Lyman's principle won out.
So this is my can opener, which is a descendant of Lyman's invention and does very much what his did. It clips on, you turn the handle, it moves round, it opens the tin, and it does the job very nicely indeed.
Conventional tin can openers have a wheel to steer you around, but with this simple design, you just guide the blade along in your own way.
The rotary can opener is still a standard piece of kitchen equipment today. But since 2014, a new technology has been making inroads in the food industry. The tear-off lid makes can opening easier and more convenient than ever before. But what is found underneath these lids can be quite surprising in some cases.
The most bizarre tinned product I've ever come across was a can of compressed underpants, sort of that size. It makes you wonder why.
What looks like a dishwashing tab reveals itself as a pair of disposable underpants when water is added. A practical idea, though somewhat silly, since you have to get them wet first. By contrast, the canned hamburger seems almost normal.
The weirdest tin can content I've ever heard of is unicorn meat, and I wouldn't have a clue what to expect in it, but apparently, once you open that can, what's inside it is really quite unexpected.
According to the label, canned unicorn meat is not only an excellent source of glitter, but also contains magic in every bite. Fortunately, no real unicorns had to die for this joke item. One of the most successful uses of the can is for beer. The sales figures are still growing steadily today. Canned beer has long since overtaken the bottled version. It made up 60% of the US beer market in 2019. But before beer could become available in cans, Americans had to endure a long, dry spell. In 1920, alcohol was banned in the United States. Prohibition was supposed to reduce crime, but actually encouraged it, since criminal gangs took over the alcohol trade.
People like Al Capone in Chicago became enormously wealthy and intensely powerful.
It wasn't until 1933 that Al Capone was sentenced to a prison term. Not for bootlegging, but for tax evasion.
The year that Al Capone was finally sentenced to prison was also the year that the Prohibition era ended.
Beer enthusiasts came up with an endearing term for the day the ban on alcohol was lifted: New Beer's Eve.
One of the few breweries that had survived the Prohibition was the Gottfried Kruger Brewery in New Jersey, which now suddenly held a pole position.
Within the first 18 hours after the Prohibition Amendment was repealed, the Kruger Brewery sold 35,000 kegs of beer. Only about 2 years later, the Gottfried Kruger Brewery launched its first canned beer. The advantages of cans were obvious. They are unbreakable, easy to transport, and keep the beer cool for a long time.
I actually think it's great because you can get canned beer to go much cooler than beer in a glass bottle. So it makes it the perfect drink for a hot summer's day.
The first year, the Kruger Brewery sold 200 million cans of beer. The taste elicited some debate. For it to be canned, beer must be pasteurized, in other words, heated to 70 degrees Celsius. For beer gourmets, this is sacrilegious. And despite this, or even because of it, canned beer had a cool and rebellious image right from the start.
The obvious thing to think about when you think about canned beer is sitting at the beach with your friends, with your family, having a beer, opening a can, having a good time.
Apparently you can get tin canned beer, and it's really, really cheap. Gosh, if I'd known about that back then when I was a teenager, things might have been a bit different.
Another cool canned drink makes a big splash on the market in 1963, Coca-Cola.
Coca-Cola was declared a cult right away. The first Coke can, also called Diamond Can because of its white diamond-shaped print, is still a sought-after collector's item even today.
Just like canned food, beverage cans were also difficult to open for a long time. The first ones came with a device that could be used to punch a triangular opening into the lid.
The decisive breakthrough came in 1964, almost 30 years after the first canned beer was sold, when the so-called lift tab was invented.
The elusive ideal can opening method is still a work in progress. Whether as beverage or food packaging, tin cans experienced a real boom in the 1950s and 1960s. Several iconic canned foods hark back to this era. In the 1950s, German parties were unimaginable without this special treat, Hawaiian toast.
I guess it must be toast with something Hawaiian on top of it? Maybe poke, that raw Hawaiian fish salad?
Isn't it toast with a slice of ham and then pineapple on top? I have to say, I can picture it. I'm not sure I like picturing it, and it does sound slightly odd now that I'm saying it.
Ham on toast, a slice of pineapple, from a can of course, topped off with a slice of processed cheese. Now that's an interesting combination.
I love my food and I like trying out different stuff, so I'd certainly give it a taste.
In fact, related creations were known in the United States and France even before the 1950s. In America, grilled spamwiches, out of a can if need be, had long been popular. But the true ancestor of Hawaiian toast is a ham and cheese sandwich from France, the croque monsieur, which was already being served in Parisian cafes in 1910. Another 1950s iconic can dish was Maggie's ravioli and tomato sauce. In 1959, it was Germany's first ready-made pasta dish. This can offered a taste of Italy, a taste of vacation.
Ravioli is delicious. Conjure up the taste of Southern Europe at your dinner table with Maggie's egg noodle ravioli. Get Maggie's ready-to-eat ravioli.
In the 1950s and 60s, Italy was the dream destination for many Germans. It combined sunshine, the beach and the sea, but also exotic food.
Since many Germans didn't own refrigerators at that time, Maggie ravioli was offered in a can. As a so-called wet, ready-to-eat dish, it only needed warming up before serving. Another 1950s American classic of world renown is Campbell's soup. The Joseph A. Campbell Preserve Company, aka Campbell's Soup Company, had already been in operation since the 19th century, producing canned soups, among other things.
The big breakthrough came in 1900 when, at the World Exhibition in Paris, Campbell's Soup was awarded a gold medal, which is still depicted on the cans to this day.
Partly due to their low price of just 10 cents a can, Campbell's instant soups were a big hit. Moreover, The company invested in extensive advertising campaigns right from the start.
Campbell's new Noodle-O soups. 2 new noodle soups that kids will come running for. With oodles and boodles of circular noodles. Spoonable, unspillable, non-skid noodles. So there's never a slip twixt the bowl and the lip. First, there's Campbell's chicken Noodle-O soup.
By the 1950s, at the latest, these soup cans had achieved cult status. They could be found in practically every American pantry.
Tomato beef Noodle-O soup.
It looks like the American pop art artist Andy Warhol also took a liking to Campbell's soup cans. This marked a departure from his usual motifs, the beautiful and the rich, including US actress Marilyn Monroe. In 1962, at the Ferris Gallery in LA, Warhol showed the initially shocked art world that a can can be an artist's muse.
Andy Warhol, the master of pop art, made a special tribute to tin cans with his famous work of art called Campbell's Soup Cans, which shows 32 pictures of different Campbell's soup cans on canvas.
In 1996, the Campbell's soup cans were sold to the Museum of Modern Art in New York for $15 million.
So the canned soups go down in history as the most expensive preserved food of all time.
It's estimated that there are currently some 1,200 different canned foods across the globe. Of these, 800 come from Japan alone. That's equivalent to 67% of all canned foods.
800 different canned goods. That's insane. How would you go shopping?
Canned food cookbooks are now available to help navigate the Japanese canned food jungle. They were written by Hayato Kurokawa, a canned food chef. In Japan, he's known as the Tin Can Professor.
For instance, when I go to a restaurant and eat something good, I always think about how to make that recipe using canned food.
One of his all-time favorites is cinnamon chicken, which consists of 1 can of yakitori, coffee cream, and cinnamon. The recipe is as follows. Heat the sealed can of yakitori in hot water for 5 minutes before carefully opening it. Add cream and cinnamon.
I like a lot of cinnamon.
Voila! Cinnamon chicken a la Tin Can Professor.
It tastes like Morocco, though I've never been there.
I guess it saves time whilst cooking, but I'm a bit dubious about whether I'd eat that myself.
Cinnamon and chicken. To be honest, it sounds interesting to me. I would try it.
I mean, it looks and sounds foul beyond all belief, but I think it's worth giving it a go.
Kurokawa discovered his passion for canned food early on. He had a first formative experience during a camping trip that he remembers well.
When I was 4, I went on a camping trip with my dad's company. That was the first time I had gomoku, mixed rice and vegetables in a can. It was about this big. You can still buy those cans.
Kurokawa insists that he only eats 3 canned meals a day. Sometimes, however, he has to make extreme exceptions as part of his job when he tests new products.
Doing magazine or TV work, I've had to try 50 cans in a day. The most I've had to try was 100 cans in a day.
Kurokawa also happens to be a passionate can collector. His collection comprises around 4,000 cans from all over the world.
When I go overseas, I always bring some home. And when friends go abroad for work and so on, they know I'll be content with a souvenir of canned food. So I can acquire canned food from places I've never been. On these shelves and in these boxes, I have about 4,000 altogether. That's around 1,000 varieties.
Such a can collection would have been a real treasure even in the 1940s. During World Wars I and II, the US government repeatedly made calls for metal donations. Americans were encouraged to donate absolutely anything that wasn't nailed down to their troops.
Pots and pans and shovels and forks and, of course, tin cans. And there were very precise instructions on how you disposed of the can.
After she washes off the label, she cuts away the top and bottom. Next, she flattens the can with her foot.
Hundreds of tons of scrap and discarded metal came together this way. It was melted down in factories and subsequently processed into new aircraft parts like this propeller. So it was the defense industry that invented the first form of metal recycling. Cans served a somewhat different purpose during the Cold War. The US was engaged in a nuclear arms race with the Soviet Union. To this end, the US military conducted numerous nuclear tests in the Nevada desert in the 1950s. Under the codename Operation Q, they tested the effects of nuclear radiation on everyday objects, including houses, clothing, cooking utensils, and canned food. A ghost town comprising 10 completely furnished houses was thus built in the middle of nowhere, occupied by dummies.
Ten houses of various different sorts were built and furnished and even given inhabitants as mannequins were set up in bed, watching television, in the cellar, hiding from the bomb.
As is customary in American households, canned food was also stored in the houses. But for testing purposes, some of it was buried outdoors. The US Army wanted to find out whether it was safe to eat canned food after a nuclear explosion.
1, 0.
On the 5th of May 1955, an atomic bomb weighing 30 kilotons was detonated over the test site.
This was not an experiment that we would do today for all sorts of reasons, but certainly we wouldn't do it in the way that they did. The experiment happened, the bomb was dropped, the area was irradiated, and then almost immediately people without protective equipment came in to see what had happened.
It transpired that even objects that were seemingly undamaged by the explosion had nevertheless been heavily irradiated and were thus life-threatening. Back in the real world, people were informed of the nuclear tests by news reports broadcast via television. Thanks to the economic boom of the 1950s, many can now afford TVs, along with many other luxury goods. 150 years earlier, the average household managed to get by with about 150 items. Now this number rose to 20,000, from toothpicks to hair-setting lotion to canned soup. And all these new products came with elaborate packaging. But once these things had outlived their usefulness, most wound up in landfills. The US was facing an acute waste crisis. Only with the emergence of the Green Movement in the 1970s and 80s did the concept of waste separation begin to catch on, a critical first step towards recycling. While cans can be recycled, they can also be upcycled by creatively repurposing them rather than melting them down.
I love upcycling anything, and tin cans are a great way of making stationery like pencil holders and desk tidies.
I certainly remember playing with tin cans as a child, you know, connecting them with a bit of string, turning them into a telephone, but can't say I've done that recently.
That this is fun is evident from looking at these recycling ideas. Tin cans are great for upcycling, but it's also easy to recycle them. In other words, to make new cans out of old ones. In 2017, about 96% of all cans were recycled in Germany, a slightly higher recycling rate than that of glass containers.
The overall ecological footprint of tin cans is a little better than that of glass. One reason for this is that canned food is lighter and therefore easier to transport.
But glass, on the other hand, requires significantly less water during manufacturing and also during recycling.
It's a head-to-head race between the two types of packaging, and in the end, the surprising winner is something completely different.
The Tetra Pak comes out far ahead in terms of its environmental impact. But even the most environmentally friendly packaging is no match for locally sourced, unpackaged vegetables. So do cans still have a future in times of climate change?
At least in 2020, sales of tin cans are skyrocketing. With the spread of the coronavirus and the consequent quarantine, food cans are more popular than ever. Sometimes they're even sold out in supermarkets because during this time, the main criterion for choosing which food to buy is shelf life. And when it comes to that, canned food is still unbeatable.
As the coronavirus started to spread, people were panic buying anything that would last, and that certainly involved tin cans. I couldn't get my hands on any baked beans.
This so-called prepping, in other words, stockpiling supplies, including food for a doomsday scenario, is a trend that's been around a long time in the US.
So-called preppers were usually laughed at quite a lot, but I suppose many of them actually felt vindicated when the pandemic started.
But the future of the can might lie not only in earthly states of emergency. Canned food, which is usually served on Sundays on the International Space Station, ISS, is a menu highlight. Astronauts consider their canned meals to be particularly delicious. The selection ranges from Japanese teriyaki to German cheese spätzle. To make canned food taste good, you need very special culinary know-how. That's because 400 kilometers above the Earth, people can't properly taste sweet, salty, and aromatic foods. The sense of taste suffers due to changed air pressure and a different humidity level. It poses a real challenge for the cooks. In space travel, every single gram counts, so the lightweight cans offer a clear advantage. The future of the can seems to be safe for the time being, at least in space. But it's more difficult to make a prognosis for earthly canned food.
I think the COVID-19 crisis has shown us is that, in fact, there is a good future for the tin can. It's a future in which we're able to preserve things just as we always wanted to.
The invention of the tin can is a milestone in the history of preservation techniques.
In opening a can that has been sealed for 5, 10, 15, 20 decades, you're like opening a time capsule in a way. It's like a little time machine, even if it's only baked beans.
Originally intended for the military, this invention soon found its way into regular households. Since then, cans are at home everywhere, in Japan, in the art world, even in outer space.
They're light, robust, perfect for transportation, even in space.
Even though the can's future is written in the stars, it's clear that nothing is as durable and resistant as cans.
I think But tin cans will always be popular. For centuries, there's been no better way of preserving food to this day.
In today's world, 7 out of 10 people live in a home made of concrete. Globally, we're producing the equivalent of 500,000 tons of concrete for every person on the planet per year. It's been used to create some of the world's most impressive megastructures. Like this, the Three Gorges Dam, spanning the Yangtze River in Hubei Province, China, is the world's largest power station. With such gargantuan construction projects and over 1.4 billion people to house, it's no surprise that China is the biggest market for this ubiquitous commodity that has proved to be so resilient. China also manufactures significantly more cement than any other country, nearly 2.4 billion metric tons in 2018.
Concrete is a material that's incredibly tough and fantastic for building. It's an incredibly versatile material that we put to great use, and that's why it is great.
Across the globe, this wonder material is used for a staggering number of projects. And every single day, the equivalent of 6.4 million truckloads of concrete are put to new use. But most surprising of all is how long concrete has actually been around. Archaeologists have found evidence of crude Stone Age concrete in the Middle East in fire pits. The fires calcined or heated the surrounding limestone rock, which inadvertently created lime. Mixed with water, it hardened spectacularly. And word spread. In Europe, there's evidence that Stone Age hunters and fishermen mixed red lime, sand, gravel, and water to construct solid floors for their huts. Concrete that more resembles the material we use today was first used by the Egyptians. They mastered their construction techniques over centuries.
They evolved over time to then develop the concrete as we know it. They would have mud and straw, and then they would join it with some gypsum and lime, and then that would make brickwork. Some of that is in the pyramid today, so it's lasted a very long time.
This great invention's versatility seems endless, yet it is a simple combination of only a few ingredients.
Concrete is made out of water, aggregates such as gravel, rocks, or ballast, and cement. And cement acts as the binding agent between all of those ingredients.
The story of concrete cannot be told without the story of cement. The different ways of making the cement glue to hold the aggregates together is the vital aspect of concrete. It's the development of better and better cement that has allowed us to use concrete in the multitude of ways we have. It's helped answer a problem present since we existed, a basic requirement of all living creatures: the need for protection and shelter. For thousands of years, human beings have sought to find ways of holding building materials together to give us better security and shelter within 4 walls. Building solid walls was an effective solution in protecting communities from invasion, such as the Great Wall of China. Cement-like materials were used in its construction, which began around 2,700 years ago. Walls built with readily available cement are used as much in modern times as in history to separate communities in times of crisis, like this one in Northern Ireland. In 1961, a stark concrete wall was built to separate East and West Germany. The German Democratic Republic wanted to stop the exodus of citizens moving over to West Germany. Construction began on a wall of concrete slabs and posts to literally stop refugees in their tracks and keep them in the east. The wall was eventually breached in 1989 and finally removed. A once divided Germany was made whole again. Walls of concrete are still created as lines of division even now. Whether in Israel, separating the Israeli from the Palestinian communities, or in the USA, where the administration wants to keep economic migrants from Mexico crossing into America. No matter the construction challenge, concrete has been the go-to quick solution thanks to discoveries made 2,000 years ago. It was the Greeks, then the Romans, who really unlocked the secrets of cement. On the beautiful volcanic island of Santorini, the Greeks discovered a way of producing a cement mix that would harden when water was added. We know this now as hydraulic cement. The key ingredient was pozzolana, which is a type of volcanic ash. When combined with lime and water, it would undergo a chemical reaction and harden. The particular mineral components, including pumicite, contained in the ash, gave it exceptional strength. It was the construction of the Roman Empire that would truly begin to harness the potential of the pozzolana-based hydraulic cement.
It's the Romans, really, who establish concrete making as we understand it. And that's because they learn from others, but they also systematize it, they also record it. And so what one finds are texts which are going to be returned to again and again, produced by the Romans, explaining how concrete is produced. Famously, the Emperor Augustus said that he found Rome in brick and left it in marble. Might as easily have said that he found it in brick and left it in concrete, because that was also part of his legacy.
The Romans embarked on huge civil and military building projects. Roman cement could withstand seawater, enabling them to also produce great maritime construction projects. The ruins of Caesarea on Israel's Mediterranean coast demonstrate the ingenuity and durability of their construction techniques. Today, stones are still bound together by cement after centuries of battering by the weather and sea. And as the Roman Empire grew ever larger, construction projects followed suit. And pozzolana cement from the Pozzuoli area near Mount Vesuvius was used in some truly staggering early Roman engineering projects. For example, the long and straight Appian Way connected Rome with southern Italy. Heavy stone blocks were cemented together with a lime-based mortar. Parts of the road were lined with monuments, and great viaducts were built along the way, pioneering examples of Roman engineering. This was a truly golden era of concrete construction.
So the Romans are using concrete for patching up buildings, for binding buildings together. They're also using concrete for massive public works. Concrete's also used for some of the great public buildings of Rome.
One of the monumental examples of Roman architecture is the Colosseum, built of stone bound together with concrete. It's still standing in central Rome after 2,000 years, thanks to the longevity of Roman concrete. The Colosseum remains the world's largest amphitheater ever attempted, although the historical details provide less to celebrate. It was built with the bare hands of tens of thousands of slaves. As well as big sporting events and games, it was also used for a more brutal and gory purpose: the showcase for gladiators to demonstrate their strength in front of a baying crowd of many thousands. They would fight to the death of one or the other for the pleasure of the spectators. But perhaps the most impressive of all Roman concrete triumphs is the extraordinary Pantheon, one of the best preserved ancient buildings in the world. Its dome, still the largest unsupported dome in the world, is made entirely of concrete. A structure that would simply never be attempted today because of our engineering codes of practice. Scientists have concluded that its strength and longevity are down to the volcanic ash they found in the mortar, the pozzolana. The Romans took their construction secret with them to their graves, leaving us almost 2,000 years later to figure out the mystery ingredient.
The concrete civilization of Rome comes to an end with the fall of the Roman Empire. We see, not just the loss of the knowledge of how to build concrete, we see the loss of all sorts of techniques, and in particularly backward places like England, they even lose the capacity to make ceramics. So what you end up with is the loss of a technology and a capacity to build big public buildings using concrete that's not going to be rediscovered for hundreds of years.
There would be a dark age for concrete for well over 1,000 years. This extraordinary Roman invention, and more crucially how to make it, was simply forgotten. By the Middle Ages, construction of homes for ordinary peasant folk in many parts of Europe was of poor quality. This Scandinavian village reconstruction shows the traditional raw building materials: wood, straw, and mud. But these homes were highly flammable, prone to rot, and had no foundations. We needed to rediscover Roman concrete, so much stronger than mud, to bind building materials together and make them tougher, more weatherproof, and durable. The revival began in the construction of something seemingly insignificant: a lighthouse. On a treacherous, rocky outcrop off the south coast of England, a lighthouse was needed to withstand the rigors of crashing waves. Civil engineer John Smeaton was inspired by the Romans' pozzolana made from volcanic ash. He used a strong powdered limestone which set hard when mixed with water. It's known as hydraulic lime.
Smeaton was riding high. He discovered the first ever waterproof concrete since the Roman times. Unlike the Romans, he designed his concrete without using volcanic ash. He used hydraulic lime. And the Smeaton Lighthouse was the perfect project to test it.
The trick was that the concrete could hold fast in rough, wet conditions. News of the humble lighthouse modeling Smeaton's new concrete mix traveled around the world.
The success of Smeaton's Tower, the fact that you could use concrete to construct these great public buildings, helps to cement, as it were, an arms race between Britain and France and between other European powers, all of them competing to try and be the first with this great new technology.
Nevertheless, engineers and architects were skeptical without further improvements. At that point, they felt it wasn't good enough to create new, prestigious buildings with. It was a fear of the unknown and the unproven.
Architects of the day were hesitant to adopt using concrete. They thought it was a reason to allow for shoddy workmanship. At the time, they were dismissive of all the new materials, such as glass panels, steel, and of course, concrete. They wanted to stick to a traditionalist method of construction, most prestigiously being stone.
But stone was expensive, especially a particular variety, Portland stone, that 18th century London had been built from. It's a Jurassic period limestone found in southern England, so not particularly convenient for builders further afield. What if there could be a concrete made to look like Portland stone, that could be produced anywhere in the world. It would mean we didn't just have a great-looking mortar, but we could make building blocks from the concrete which would look as good as expensive, handsome Portland stone, but without the cost. It took a lot of trial and error to find the right combination of finely ground limestone and clay to match the real thing. Finally, the turning point, an artificial stone using what became known as Portland cement.
The British are, I think, the leaders in this, and they're the leaders in this because they are also leading in the Industrial Revolution. There is money to do this, there's demand to do this. The British are building vast docks, they are building huge, great public works, they are already engaged in the process of canalising the country, of producing railways eventually. All of these things drive the demand for new and better building materials. And Portland cement is one of those new and better building materials.
The invention of Portland cement was a huge breakthrough in concrete technology. In fact, it's now the most widely used manufactured material at around 3.5 billion tons each year. Portland cement forms the basic mix of concrete used throughout the world. Cement gives us amazing possibilities, and it's not just buildings and roads. There are many exciting applications in interior design. Concrete's surface can be polished to give it a high shine. It can be treated and celebrated.
Concrete's not just a straight-up building material or a glue for things. A lot of people actually find it aesthetically pleasing. You can make it really quite nice, you know, with buffing it up and shining it and things like that. And also, it's used in a lot of artwork as well. So not only is it a building material that has great uses, but it's actually sort of pervaded many other sectors.
You can stain it like this, or add textured patterns to replicate wood, for example. Or just spray it a different color. You can install furniture made from concrete. Sleek, comfortable finishes make you forget the hardness and rigidity of the static structure you're sitting on. And you can chop your vegetables on a polished concrete worktop if you like. It can be a remarkably resilient design feature in a modern kitchen.
What I love about concrete is concrete doesn't have to look the same all the time. Concrete can have so many various finishes. I mean, the possibilities are endless with the finishes you can achieve with concrete.
From decoration to record-breaking, concrete can stretch our engineering capabilities, like building tunnels. At 35 kilometers long, this is the longest undersea railway tunnel in the world, and the largest engineering project ever undertaken anywhere, ever. Filmed during its construction in the late 1980s, it connects mainland Europe to the main island of Britain. It's a modern marvel, recognized as one of the 7 wonders of the modern world, and it's built of concrete and steel. The tunnels were lined with tailor-made rings made from a high-intensity concrete, designed to last for 120 years. We're good at building tunnels, and we're good at digging other holes to harvest and exploit our natural resources. None more so than by repurposing the very ground we walk on. In massive quarries like this one in Switzerland, aggregate is systematically gouged out of the ground and then processed, ready for use in construction. So exactly how do you make concrete to get that impressive Portland stone look? Much like preparing a simple cake mix, the key to making good concrete is using the correct proportions of each ingredient. But the method itself is straightforward. First, mix the Portland cement and water to make a paste. A chemical reaction called hydration will occur, and lots of microscopic crystals will form. Next, add your aggregate, either fine like sand to make a smooth paste for mortar in a building, or coarse, which can prove cheaper to use. Whatever the grade of aggregate, make sure that it is completely coated with the paste. Finally, ensure that the magic ingredient, air, is allowed in as you mix. Air makes the mix easier to work with and improves the concrete's ability to withstand both freezing and thawing. No baking required. Use straight away and it will set within a few hours. Perfect. It seemed that concrete was never going to be fit for the kinds of purposes we had in mind. As well as changing the color, which was achieved with Portland cement, concrete had to be improved to make it more reliable structurally. But how could concrete be made stronger? Building in concrete had to change. We had to have confidence in our structures that they would stay strong and last. The answer lay in the developments that came with the Industrial Revolution.
So concrete's not the only new building material of the 19th century. Steel is being produced in industrial quantities. Plate glass is being produced in hitherto unimaginable quantities. And architects and engineers are actually much more interested in those two new sorts of building materials.
In France, concrete construction was to take its largest step forward for centuries. But this time it would not be a world-renowned engineer to make the breakthrough. It was a French gardener who simply wanted stronger flower pots. And he turned to the other newly available commodity, steel, to provide the strength he was looking for.
So really the important change is the introduction of steel reinforcing rods through the concrete. I mean, what that does is to transform the nature of concrete. It makes it stronger, it means you can build higher, you can build bigger, you can build quicker. In every way, it revolutionizes concrete and as a result revolutionizes building throughout the world.
Inserting the steel rods into the concrete before it set was genius. Crucially, this reinforcement made the difference between trust and mistrust of concrete.
Steel would give it the tensile strength and the concrete would give it the compressive strength. Other engineers started to see the benefit of this, and they started expanding the technique to railway and to bridges.
And so concrete becomes, in the minds of some, the modern material and the basis for modern architecture for centuries to come.
What followed at the beginning of the 20th century was nothing short of a concrete building gold rush, evidenced in these great American icons built at that time. Industrialization had already come to cement production as well as to steel, so that both were readily available and at scale. This meant we could build quantity as well as quality in concrete. But it took a cataclysmic event to take concrete to the next level. The San Francisco earthquake of 1906 killed thousands of residents. It destroyed a staggering 80% of the city. 500 city blocks were wiped out. A few reinforced concrete buildings survived, indicating that if homes had been built of concrete instead of wood, the devastation would not have been so great. Instead, buildings went up in flames. The damage was valued at $8.2 billion in today's money. Rebuilding better, stronger, and fast was the #1 priority, and concrete was a major player. Among the American engineers who grasped that notion of building quickly and strong was a prolific inventor, not known for architecture. Thomas Alva Edison was possibly best known for world-changing inventions like the incandescent light bulb. He became obsessed with the possibilities that came with concrete, even founding his own Edison Portland Cement Company.
Concrete looks to Edison and to some other people as the single best way of producing factory-like building, of mass-producing architecture, using the properties of concrete to provide social housing, schools, roads, cars, and indeed almost everything you find within a home.
Thomas Edison was a thought leader of the time. He wanted to see if he could create everything in concrete. Now imagine that. Everything, housing, everything inside your house, even your fridge out of concrete.
Edison's vision was to create indestructible but affordable homes like the model he's standing next to. But others designed for mass production weren't quite what people were looking for. They were deemed ugly. Edison was full of great ideas, but this one needed rethinking. Elsewhere in Europe, one thing that was successful was the road system. At the end of the 19th century, the French were leading the way, experimenting with non-reinforced concrete roads. But as building work with reinforced concrete began, it was evident that the infrastructure connecting towns and cities also needed reinforcing. At roughly the same time as this new road building craze was happening, a great friend of Edison, a man named Henry Ford, produced his first Model T car, and the American road network began a fundamental transformation. Edison jumped on this construction bandwagon too, and tried his hand at road building for his friend Ford's cars to run on.
Edison's interest in assembly line concrete house building was very like the interest of his friend Ford in producing the Model T in these Fordist assembly lines. And they are friends, and they have mutual interests, and this idea of mass production is in the air. And so what's happening is that at the same time that Ford is producing the people's car and Edison is trying to produce these concrete people's houses, all these cars are being produced. The houses aren't, but the cars do need something to run on. And so concrete roads provide one answer to how the Model T is going to get about.
American road building escalated quickly alongside what became a national passion for cars. The U.S. can now boast the largest network in the world, with roughly 6.6 million kilometers of roads, followed by China and India, where research suggests that for long-lasting roads, concrete is the solution. There was another concrete construction boom in 1930s America, despite the Great Depression. U.S. federal buildings that were due to be built with stone were instead built in concrete. And it was the beginning of engineering some truly astonishing concrete creations. The staggering scale of building the Hoover Dam, for example, which demanded an incredible infrastructure to support it. Not least the planning and building of Boulder City. The land was nothing but desert in Nevada before construction began of a brand new town in an experimental style that had never been tried before, largely in concrete. The engineers and surveyors were housed first as they prepared for the construction of the dam. Then, a train station was created. The workers' accommodation was next. Thousands of modest homes, plus all the infrastructure for a town. Public buildings, utilities, schools, a hospital, and churches. Within a year, a town of 5,000 inhabitants was established. Streets and streets of houses where everyone who lived there worked on the dam in some capacity. The dam was providing much-needed jobs to the American workforce at a time when unemployment was high because of the economic depression. And it rose so quickly out of the desert thanks to the speed with which concrete could be mixed and used. Every component of the construction of the dam was on an epic scale. This one project required the same quantity of concrete as a full-sized highway across the United States, 4,800 kilometers long. More than 5 million barrels of Portland cement went into the dam. The project, initially named Boulder Dam, harnessed the power of the Colorado River with the aim of creating enough electricity to supply the whole population of California. Today, it provides electricity to 1.3 million people living in 3 states and remains one of America's biggest power plants. Providing housing on a mega scale and fast, like they had to in Boulder City, is still a challenge in the 21st century. Refugee crises like the one that caused this camp to be built in Turkey mean many thousands of people have to be given shelter quickly. Several camps in this area house tens of thousands of refugees from the conflict in Syria. Now, there is a quick, robust solution to providing them with temporary homes. Technology has been developed that allows concrete shelters to be constructed in ultra-quick time. A team in the UK have come up with this. It's like an inflatable home, except that as well as air, you add water. The concrete sets to provide a solid, weatherproof refuge.
Concrete canvas is a fabric that's filled with a dry concrete powder with a waterproof PVC membrane on the rear surface. We developed the material to get another invention that we had to work, and these are called concrete canvas shelters. These are rapidly deployable, inflatable concrete structures for disaster relief.
This idea sparked another, which could revolutionize the construction industry, thanks to its simple application. Concrete on a roll, which can be laid as a ditch lining, for example.
It's flexible before use. It's then laid over whatever surface you want to cover in concrete, typically a soil structure. Once in place, it's sprayed with water. That hydrates the cement component, and in 24 hours, the concrete sets, and you have a hard, fiber-reinforced concrete layer.
It's said to be 10 times quicker than conventional concrete mixing, laying, and setting. Speedy solutions are in demand to enable construction in times of crisis, such as even a housing crisis. But what came along to alleviate European post-war homelessness wasn't to everyone's taste. Ever since we've had buildings made of concrete in the modern era, critics and fans have been divided. But one movement caused more of a rift than most: brutalism. And the man behind it was known as Le Corbusier. He was a tour de force and a leader of a movement opening other architects and the public's eyes to a different way of using and seeing concrete.
They start to use concrete because they believe it's beautiful. They start to use concrete because they believe that you should show your building is concrete.
Concrete was the material of the future, a sign of forward-thinking architecture in both the capitalist West and communist East. It would be a true golden age of unashamed concrete construction. Architects were celebrating the material, not hiding its flaws. Le Corbusier's L'unité d'habitation in Marseille shows the simplicity and functionality he had in mind. Brutalist buildings, characterized by their monolithic appearance and rigid geometric style, were made with large-scale use of poured concrete. With a huge population boom around the globe, this brutalist architecture lent itself to building for the masses. Brutalist buildings fell out of fashion in the 1980s and were vilified by many for decades to come. But now they are enjoying a renaissance, and instead of being threatened with demolition, brutalist buildings are being celebrated. However, the world's passion for concrete construction resulted in a lack of green space, which led to the description of our cities as concrete jungles. An ironic term, given that concrete is now thought of as a large contributory factor to our climate change issues and ever-rising CO2 levels in Earth's atmosphere. The global cement industry was said to be responsible for between 4 and 8% of the world's carbon dioxide emissions in 2019. In fact, it's been suggested that if the cement industry were a country, it would be the third biggest emitter of CO2 in the world, behind China and the USA.
Manufacturing concrete typically generates a lot of CO2, and we don't need any more greenhouse gases emitted.
So though there is a lot of negative press about concrete in terms of its embodied carbon and kind of the CO2 involved in the production and use of concrete, it's no worse than many other materials. I think the problem we often find with concrete is we use it in such huge quantities that it ends up scaling up to being quite significant.
Production of cement has quadrupled globally in the last 30 years. In China, production is 12 times more than it was in 1990.
We look at cities today and a lot of it is built on concrete. That may be changing, or at least the way that we make that concrete might be changing, because cities are going to become smarter. We're going to be having more technology built into our cities, but we also need to be using more green technology, making them more sustainable so that they don't have such an environmental impact. And that is going to affect how we make cities in the future.
Green design ideas may be part of the answer. Shanghai's 1,000 Trees construction project is injecting some missing greenery and oxygen to this part of the pollution-choked city in the 12th most polluted country in the world Air Quality Index in 2018. It's described as a tree-lined mountain with a plantation of indigenous trees hugging every level of the unusual design. Hundreds of concrete columns were used to distribute the weight of the trees to the ground. Living walls bring carbon-consuming plants and trees into our urban spaces. The downside is the support required in terms of planting, watering, and pruning of the vegetation.
So much research is being done on concrete to try and reduce carbon dioxide emissions. It's of real interest right now.
Concrete development is looking to go further than simply greening up. Bioconcrete is being developed that will grow plants from pores on its surface. These new systems do away with the need for soil or irrigation. This kind of technology could literally change the way we look at concrete in years to come, making our view of the built environment greener, as well as improving air quality. Concrete has already allowed architects to design some extraordinary buildings with wonderfully flowing lines. The Sydney Opera House, with its precast concrete shells, is a magnificent example of the flexibility concrete can provide. In its harbor home, they look like sails filled by the wind, making it one of the most iconic buildings in the world. The execution of this original design was achieved using early computer technology. Today and in the future, that technology will enable more modeling and pre-planning to cover every eventuality. 3D printing is one of the ways forward, automating many of the processes. This is claimed to be Europe's first 3D printed building. The BOD, an acronym for Building on Demand, was installed in Denmark in 2017. It doesn't have any straight walls, proving that 3D printing gives designers fantastic versatility without incurring huge costs. It took 2 months from start to finish, but the designers say they've been able to speed that up to 3 days. These new innovations in concrete are already changing the way we build, perhaps even fueling our appetite for this brilliant invention. Concrete's reputation is a sturdy, solid, dependable one. Some buildings around the world have been built in concrete to exude those qualities, their very being meant to inspire confidence. Power stations, for example. Massive, important-looking steam towers stand out on the skyline as familiar man-made landmarks, reminding us of where our electricity is being produced.
When we use concrete for nuclear power stations, I think there's almost some public confidence, public perception of confidence when you see a concrete structure. It's durable, it's gonna last the test of time, I'm safe. So sometimes I think the power of concrete isn't just its material qualities, it's actually the emotional associations that we as human beings have put on concrete. Concrete makes us feel safe.
But concrete is not strong enough to save us from a catastrophic disaster like this one. Chernobyl, 1986. Explosions in one of the reactors made it the world's worst nuclear accident. The subsequent fire burned for 10 days, releasing a large amount of radiation into the atmosphere. 2,600 square kilometers in Ukraine and Belarus will be contaminated by radioactivity for at least the next 24,000 years. To try and lock in the remaining radioactive materials, a shell was rapidly constructed using 400 cubic meters of concrete. But it wasn't sealed properly. Years later, radiation levels outside were rising, and the structure was in danger of collapsing. Work began by laying new foundations with 20,000 cubic meters of concrete ready to support a tailor-made casing designed to seal within it the damaged plant and the remaining radioactive material. In an unprecedented operation in 2016, this giant steel shell, called the New Safe Confinement, was rolled into position. It's the world's largest movable object, measuring 257 meters long by 109 meters high, and it's strong enough to tolerate a temperature range between -43 and +45 degrees Celsius, as well as tornadoes and earthquakes. It's designed to last for 100 years, by which time it's hoped a longer-lasting solution will have been found. In the meantime, this massive sarcophagus is keeping us safe from Chernobyl's toxic radioactive ruins. When we build nuclear power plants today, safety is absolutely paramount. 3 million tons of concrete will be used in one of Europe's biggest infrastructure projects to supply millions with low-carbon electricity. But some countries shun nuclear power, opting for planet-friendly alternatives. Concrete foundations support wind turbines and hydroelectric installations. It also has a playful side. Providing a great surface for skateboarding. Invented in the 1950s by Californian surfers wanting to surf concrete. These days, there's a wealth of urban explorers and adrenaline junkies reveling in the concrete playgrounds of our towns and cities.
If you're a skateboarder, you want a concrete jungle. You want the mayhem of the smooth concrete surfaces to bomb down on. They're fantastic to have that fun experience on.
So too, in the land of movies, celebrities can have fun taking part in an iconic celebration of the stars, cast in concrete. The story goes that the owner of the Chinese theater in Los Angeles accidentally stood in wet concrete during its 1927 construction, sparking the idea for celebrities to do the same. More than 200 Hollywood greats have planted their hand and footprints so far. Will the Hollywood handprints stand the test of time? Will they have the same enduring quality of the early Roman concrete used 2,000 years ago? As concrete is the second most widely used substance on Earth after water, its lasting legacy will surely endure.
The thing with concrete, and indeed steel, is that they have massively scaled. They're industries that can handle the amount of building that we do, and we do a lot of building. And as we have more and more people joining us, stabilising at about 11 billion of us by the end of the century, they're going to need somewhere to live. So I think we're not going to see concrete or steel replaced by anything soon, just because of the supply side of it. You can come up with a new material or whatever, but you just don't have enough of it to handle the amount of demand.
Concrete has dictated the way we build. It frames our existence and has provided solutions to seemingly impossible problems.
Concrete is a great invention because it's just such a versatile material. It has led to the building of cities and buildings that we really need to use. It's allowed cities to thrive, and also it's incredibly useful in other things.
Do I love concrete? I think I do. I really think I do. It's created the countries we live in all around the world. It's created a society that we all have now, where we have great roads, great infrastructure, big bridges, railways. Without concrete, we wouldn't be here today, living the lives that we so very much love.
This plain-looking, ubiquitous material has transformed our built environment the world over. Some find it has a beauty all of its own. It has stood the test of time and survived disasters both natural and man-made. It has stretched our capacity to house ourselves and our industries and workplaces and fills us with a warm sense of security. Without it, every street, every city would look utterly different. Concrete is a great invention.